This is a short tutorial to help you review how to get to the lowest structure of any covalent compound using the nasal method. The first step will be to find the number of bonding and lone pairs of electrons to be distributed between elements of that compound. The N for nasal stands for needed electrons, which is obtained by adding all valence electrons once each element has reached the noble gas configuration, which means having 8 electrons for all elements except hydrogen, which is satisfied with only 2, beryllium satisfied with 4, and boron satisfied with 6. The A stands for available electrons, which is obtained by adding the total number of valence electrons for each element of that compound with addition of extra electrons if we have a negative polyatomic ion, and taking away some electrons if we have a positive polyatomic ion. The S here stands for shared electrons, which is obtained by subtracting the available electrons from the needed electrons. And finally, what's left will consist of the lone electrons, subtracting the shared one from the available one. So let's see how this method can help us get through to the lowest structure of that particular polyatomic ion, PO4 3- or phosphate ion. Okay, so let's see how we can get to the number of shared and lone pairs of electrons in phosphate ion, PO4 3-, so 1 phosphorus and 1, 2, 3, 4 oxygens with an overall charge of 3-. All of these elements are satisfied with 8 electrons in their valence shell. So we have 8 plus 8 plus 8 plus 8 plus 8, so 5 times 8, which makes 40. Then we have to count the total number of available electrons by looking at the number of valence electrons that each will bring. Phosphorus will bring 5, and each of those oxygens will bring 6. So 6 times 4 plus 5. Added to the charge of the negative polyatomic ions. So we have a charge of 3- here. So we have to add 3 additional electrons to the available electrons, which brings us to 32. Next step, we're getting to the number of shared electrons by subtracting the available from the needed, so 40 minus 32, which is 8 electrons or 4 bonding pairs. And the last step, getting to the lone electrons, subtracting the share minus the available minus the shared, so 32 minus 8, which is 24 electrons, also 12 lone pairs. Okay, now that we have the number of bonding and lone pairs of electrons, we need to identify which one of these elements of the compound plays the role of the central atom. It's usually the first element of the formula. Hydrogen is never the central atom, and if you have more than one element to pick, you have to look at which one is the least electronegative. So in our case, we have to pick between phosphorus and oxygen, and looking at the electronegativity trend, we can determine that phosphorus is the least electronegative compared to oxygen, so phosphorus is the central atom. So now the last step will be to arrange those pairs of electrons to get to the lowest structure of our molecule, PO4 3-, knowing that the central atom is phosphorus, that we have 4 bonding pairs and 12 lone pairs. So we're going to start by placing those elements, phosphorus at the center and oxygen surrounding it. And now we're going to arrange the 4 bonding pairs, starting from phosphorus. Here 4 around phosphorus. If you count the electrons surrounding phosphorus, you have now 2, 4, 6, 8 electrons. Phosphorus is satisfied. We're now going to place the lone pairs, 12 lone pairs to place in this structure. We're going to put those lone pairs around those oxygens. And now if you count the number of electrons surrounding this oxygen, for example, we have 2, 4, 6, 8. 2468 for this one as well. 2468, 2468. Every one of these four oxygens have now reached their noble gas configuration. And to complete the structure, we have to add a bracket in order to put the overall charge of that polyatomic ion 3 minus.